this particular video, we are going to be implementing a simple machine learning classification problem based on the car data. We are going to see certain features such as price of the car, then mileage of the car, then we are also going to be seeing what particular brand does this car belongs to, and then we are going to do some feature engineering, and finally we would be able to see the classification results based out of this machine learning problem. So let's jump into the code. And as you can see, I have imported pandas and numpy for creating and manipulating the dataset. Then I have also imported trend, test, and split, which can split the dataset into training and testing sets. Then I have also used label encoder, which can encode categorical variable into numeric values. Then I have used standard scaler, which can scales numerical features to standardized them, meaning mean of 0 and variance of 1. Then I will be using here logistic regression, and then we are importing certain metrics for evaluating our classification performance, which is classification report, then ROC-AUC curve, and then ROC curve, sorry. And then we will also be importing SMOT, which is synthetic minority oversampling technique for balancing imbalanced dataset. And this particular technique we will go much into detail into our next video, but right now you can import this by from using imblearn library, and then finally we can use matplotlib for our data visualizations. We are going to create a number of samples into our dataset. So for this particular example, I will include 500 samples of cars, and we should do num samples equal to 500. I have created a list of brands using Toyota, Honda, Ford, BMW, Audi, and so on. And then I have defined those models of those cars, and then I have also included fuel types. Now let's also include the number of years. I'm gonna do that by using random integers. I'm gonna go until 2023. So let me actually think and write a few features for our car dataset, and I will be back shortly. Perfect. So this is what I came up with. I also included the mileage, then fuel, brand, model, and even the prices. So let's run these two cells. Perfect. I'm going to create a data frame here, and as you can see, I have associated brand from here to my new name brand, which is B is in caps, then model, then years, mileage, and then fuel and prices. Because prices can come from here, it's between $5,000 to $60,000 with those num samples, and it would fill all the num samples, which is 500 rows. And similarly for those mileages as well, anywhere between 5,000 to 150,000. Let's run this cell. Perfect. So now what we can do is we can implement feature engineering, and for feature engineering, let me include car age as a new column. So how I will do is I will include car data with square brackets, and this is my new column. So what I'm going to do is I'm going to minus from 2024, and then Perfect. So this would give me the age of the car, which is current year minus the manufacturing year, and it will add as a new feature called car age. Let's run this cell. Now what we will do is we will define a binary target variable, and I already defined here. So let me paste it over here. So what this is going to do is it will assign one with all the car prices about $20,000 and 0 with car prices less than and equal to $20,000. So let's run this. Awesome. Now what we are going to do is we need to convert brand, model, and fuel type, these three values, into numeric values. So for that, we are going to use a label encoder. And how we can use label encoder is this is how we can implement it. Perfect. So now brand, model, and fuel type must be converted into numeric values. We have done our feature selection, and into my X I have included brand, model, car age, mileage, and fuel type, and I have defined my target variable as price category because that is what we are going to classify. So yeah, define my X and Y values. Let's run this cell. Okay, so now I think we can do the standardization of those features. So I will be implementing standard scaler, which will have a mean of 0 and variance of 1 for X features, which can improve our model performance. So this is how I will be implementing it. So let's run this cell. Perfect. I know at the start of our programming time, I have told you guys like we will be implementing sport, but we don't need to really go into much detail. So for assignment purpose, I will just go ahead and implement the smooth. So what this is basically going to do is it's basically going to balance our data set. So smooth generates synthetic samples of the minority class, which is underrepresented price category in this case, to balance our data set. Now we will do the trend test split, which can be done this way. And as I said, in this particular program, I'm going to implement logistic regression. So we would be implementing logistic regression this way. I'm going to fit those models into X train, Y train, and we are going to run this program. Perfect. So let me include some couple of cells down below. I will just, okay, now I have a couple of cells. Let's make predictions out of it. So ypred is our standardized method of naming those variables. Then we are going to do predict on my X test, followed by Y probability, on my X test. So what this will do is ypred will predict classes either 0 or 1 for the test set, and then my Y probability is predicted probabilities for the positive class, which is price greater than 20,000. So I hope You understood this? So let's run this cell. Perfect. To evaluate the performance of this machine learning problem, we are going to import this classification report, which we have already defined into our program from here. And then we are going to see ROC AUC score confusion matrix. So let's run this. Now let's plot a ROC curve, and for that we are going to using this particular set of code, and we don't really need to dive deep into each line of this code. We are going to cover all these topics into separate videos later on to give you guys in-depth knowledge of what exactly FPR TPR means. But right now all I can say is it can calculate our false positive rate and true positive rate. So those of you who are familiar with the machine learning concepts are able to understand what I'm trying to say, and they are used to evaluate our model performance at different thresholds. And AUC indicates overall model performance. The higher the AUC, the more better the model is. We will run this, and boom, we have our first ROC curve. Great. Now lastly, I think we need to also be implementing our classification report metrics, and for that what we are going to do is we are going to print our classification report. Oops, should be report. And then lastly, I'm just going to copy paste this. And here I'm going to write confusion matrix. And lastly, we are going to write ROC AUC score and change here to, what was the name we have given? It's confusion matrix. Okay, this name is ROC AUC. We don't need to give slash in here. I think this will do. Perfect. So we have got our precision recall F1 scores, and we have got our accuracy score as 0.5. So again guys, here we also have the confusion matrix, then we also have the ROC AUC curve, which is 5820, 0.520, and we don't really need to get into details of this. First, this we have created this particular machine learning program of this car data just to give you guys sense of how we can be implementing this machine learning problem using car dataset. So get familiarized with the concepts and the details, and as you guys become more and more experienced with this particular data science and machine learning, we can dive in depth into each and every concepts of those machine learning. This is it guys. So we have finally implemented our classification machine learning problem based on the car data. So feel free to go through all the steps of the machine learning problems which we implemented, and feel free to pause the video and try to question yourself what exactly you guys are trying to solve. And if you have any questions, you guys have my email ID on my YouTube channel, So feel free to send me your queries. I will be answering them. And for now, I think we are done here. So into our next video, I will try to pick some topics regarding NLP or large language models, and we can go from there.